All right, so first question. Define the term isotope. Same number of protons, different number of neutrons. Therefore, a different mass number, even though we're talking about the same atom. All right, skip down to number 3. What is the most common isotope of carbon? So I come over here in my simulation. I click on carbon. I want to see, for carbon-12, what the abundance in nature is. Well, 98.93 indicates that that is my most abundant isotope of carbon in nature. If I bump it up to carbon-13, I only have 1.07% of all carbon. That is carbon-13. If I bump it up to carbon-14, the isotope carbon-14, now I have a situation where I have a very trace amount of carbon-14. So, that answers question 3, 4, and it answers question 5. Take a look at question 6. What has a higher percentage abundance, oxygen 17 or 18? Click on oxygen. I can clearly see the most abundant isotope of oxygen is oxygen 16. If I push it up to oxygen 17, 0.038% is oxygen 17. Oxygen 18, though, by comparison, there's a larger percentage of oxygen 18 at 0.205. So, oxygen 18 has a higher percentage abundance. What are the 2 isotopes for boron? Click on boron. I can clearly see boron 11 has a percentage, so that's 1 isotope. If I add a neutron, hey, look, there's 0% boron 12. This doesn't exist. Let's try taking away a neutron. Hey, look, boron 10. There's 19.9% boron 10. The 2 isotopes of boron is boron 10 and boron 11. Hey, what is average atomic mass? How does it relate to isotopes? Anybody have an answer for the last one? It's not just an average of the average mass of what? So in this case, we're looking at the percent abundance of various isotopes that exist for each element. So carbon has 3 isotopes, carbon-12, carbon-13, carbon-14. If I take all the carbons in this world and average the masses together, I get an average atomic mass of, take a look on the periodic table, 12.0107. That shows me that the vast majority of carbons in this world are of what isotope? Carbon-12. If I had 1 carbon-12, 1 carbon-13, 1 carbon-14, what would their masses average out to be? Carbon-13. But again, I have a whole lot more carbon-12 in this world, so the average is actually closest to 12, 12.0107. Hey, take a look at the other simulation that you can do with this one. So instead of choosing, come on, work, isotopes, let's go over to mixtures. So here, if I go to the nature's mix, if I click on carbon, look at the image. The vast majority of carbon is indicated as being what? Carbon-12. So you can see the carbon-13, every 1 in so many will be carbon-13 scattered around. You can see right here on the average atomic mass that it's closest to carbon-12 over carbon-13. If I go to oxygen, kind of similar. Oxygen 18, you see 2 of them per a lot of oxygen atoms. Chlorine, on the other hand, you see a higher percentage of each of your isotopes, chlorine 35, chlorine 37, A higher percentage of each represented in the diagram. Boron, again, somewhat similar to chlorine, where a higher percentage is represented by both of the different isotopes.